This is A-Level Mathematics, Chapter 11, Curves Defined Implicitly. So let's start with the equation of a circle with the centroid of P comma Q. So P is my X value, Q is my Y value, and a radius of R. So this is going to be the standard notation of a circle where I have X minus P squared plus Y minus Q squared is equal to R squared. Now, if we're going to find the equation of the circle with the centroid of here and the radius of 3. So I can go ahead and just plug it in because there's my P, there's my Q, and my R. So I'm going to have X minus 1 squared plus Y minus 2 squared equals 3 squared. Now, common notation right here. Now, sometimes you might see it expanded. So if it's expanded, we would go ahead and distribute all this. So it's going to be x squared minus 2x plus 1. So I'm actually distributing all that. Plus y squared minus 4y plus 4 equals 9. Combine like terms. And so I go x squared plus y squared minus 2x minus 4y. So combine all this, I get 1 and 4, that gives me 5. It gives me 5 right here, so it's going to be plus 5 equals 9. So I'm going to move it to either side of this, and this would be another way that you would see this commonly. You'll see it moved over to this side right here, because this is always going to be set equal to 0 for these equations. So it would be x squared, that's an x squared, plus y squared minus 2x minus 4y. Now move that over here, I get negative 4 equals 0. Now on this next problem right here, we have find the centroid and radius of the circle given this equation right here. So to solve this, we're going to go ahead and complete the square. So completing the square, so I'm going to separate my x value, my y value, and move my constants over to this side right here. So I'm going to make it into x squared minus 2x plus something plus y squared plus 4y plus something equals 7 plus something plus something. This is that something, this is that something, because whatever you add to one side, you must also add to the other. So keeping the equations balanced right here. Now, to figure out what this is right here, you take this one right here, divide it by 2, and square it. So negative 2 divided by 2 is negative 1. Square it, that's going to be positive 1. So I'll write it down over here, so just in case you're not listening to it with the volume up. So this right here is going to be b divided by 2 squared. And that's what you're going to plug in over here. That's going to give me 1. Same thing over here, so it's going to be this one. Divided by 2 is 2. Squared is 4. Right there, so now that goes over here, 1. And same thing goes over here, 4. Now, this one right here is just going to be this. So it's going to be x. Now, divide this by 2. So this one right here is going to be a negative 1 squared plus, right here we have y. And for this one right here, it's going to be this divided by 2. So it's going to be plus 2. And that's going to be squared equals, that's going to give me 8, 12. Now, I have my P, I have my Q, but I do not have my R. So my R, if we go back to the formula, it's going to be R squared. So I'll go back up here, R squared right here. So now to figure out what R is, I'm going to take the square root of that right there. So let's go ahead and take that. So it's going to be, P is going to be 1. Because it's going to be right here. It's a minus sign here and a minus sign here, so it's going to be the opposite of those. So it's going to be 1, comma. Right here I have a positive 2, so that's going to make it a negative 2. Close. There's my P, comma Q in my centroid of this. And my radius is going to be the square root of this, so it's going to be square root of 12, or I could write it as 2 square root of 3. So factor it out. I'll accept either answer for this. Now on 11.3.1 it says show that point 1, 2 is on the circle, right here given that, and find the gradient there. So first thing I have to do, I have to prove that it's on the circle. So if I prove that it's on the circle, I'm going to plug in my x and y, and it should be equal to 0. So it's going to be 1 squared plus 2 squared minus 6 times 1 plus 2 times 2 minus 3 equals 0. It's going to give me 1 plus 4 minus 6 plus 4 minus 3. So right here it's going to be 5, that's negative 1. That's going to be a positive 3, that's negative 3. So all together that is equal to 0. So that is going to be true. So that means that that point right there is going to be on my circle. Now to figure out my slope there, I need to take the implicit differentiation for this. So I need to take the derivative of both of these. So when I do this, I'm going to take the derivative according to x, but I have to do the same thing for the y, and I'll show you how I do that. So derivative of this is going to give me 2x plus, now if I was taking the derivative of this, it would be 2y, but now I need to state that I'm not taking the derivative of x for this, I'm taking the dy dx. So every time I'm actually doing the derivative for the y when I'm actually not deriving the y in this equation right here, so I need to have a dy dx. So that means that this is not of my x value here. So right here I get minus 6, and this is going to be plus 2 dy dx, and that becomes 0 equals 0. Now we're trying to find the slope here, so I'm going to go ahead and I'm going to, let's take a look, I'm going to plug these in, and I'm going to solve for my dy dx. So plug in my point, which is 1, 2, so this is going to give me 2 times 1 plus 2 times 2 dy dx minus 6 plus 2 dy dx equals 0. It's going to give me 2. This is going to give me negative 4. So that's negative 4. This right here is 4, and this is going to be 2. So if I were to combine these together, I would get a positive 6 dy dx equals 0. Move that to the other side, and I would get 6 dy dx is equal to a positive 4. Divide both sides by 6 to get my dy dx by itself, and I should get, so dy dx is equal to 4 divided by 6, which is going to be 2 over 3. So my slope is going to be my derivative at that point. So I take the derivative, I plug in my point, and that gives me the slope right there. Now let's take a look at this next problem right here. Find an expression for dy dx on the curve right there. So I'm just going to find an expression, get dy dx by itself. So let's go ahead and take the derivative of this, which is going to give me 6x minus, derivative of this is going to be minus 6y squared dy dx equals 0. So if I move this over to the other side of the equation, it would be a negative 1. Take the derivative of the negative 1, it just goes away anyway. So all the constants here will go away. Move this to the other side. Negative 6 dy dx is equal to, if I move this over here, I get negative 6x. I kind of lost my y squared here, so there is a y squared. So I get a negative 6y squared. Can't leave that one out right there. Okay, so I have negative 6y squared dy dx. Now to get dy dx by itself, divide by negative 6y squared. And so right here my negatives will cancel, my 6's will cancel, so that I'm left with dy dx is equal to negative negative that goes positive x over y squared. So I found the expression for this one right here. I simplified it, and if I was wanting to find at a certain point, I would plug in my x and y value here, and that would give me my slope of my derivative at the point. Now chapter 11.3.3, find the equation of the tangent to cosine x plus cosine y equals 1/2 at the point pi over 2 and pi over 3. So let's go ahead and do the derivative. The derivative of cosine is going to give me negative sine, so this is negative sine x, and this is going to become same thing, so it's going to be minus sine y dy dx equals 0, because again right here that's a constant. When if I move it over there, it's going to take the derivative and it goes away anyway. So let's go ahead and let's move this over. So for right here, move that over, so I get negative sine y dy dx is equal to, if I move that over there, I get positive sine x, divide both sides by negative sine y, so I get dy dx is equal to sine x over negative sine y. Now let's go ahead and plug these in. So sine at pi over 2, so the sine value at pi over 2 should be a 1. So sine at pi over 2 is 1. And now for this one over here, so let's take care of my sine first. So sine right here at pi over 3, so sine at pi over 3 should be square root of 3 over 2. So I have square root of 3 over 2, and since there's a negative outside there, I make that negative right there. Multiply by the reciprocal, and I should get negative 2 over radical 3 as my answer here. So the only thing that's left is actually to rationalize. So dy dx comes out to be a if I were to rationalize that, I'd come up with a negative 2 radical 3 over 3, or also referred to as my slope, so it would be m is negative 2 radical 3 over 3. So now I got the slope part of this right here. Now the next thing is find the equation of the tangent. So I have the x value, I have the y value, and I have the slope right here. So let's go ahead and start working that out. So if I plug it into my slope-intercept equation, I should have y minus pi over 3 equals negative 2 radical 3 over 3 quantity x minus pi over 2. Go ahead, distribute. I get actually, I think the way that the book works this out for your answer is they will get rid of your 3's. I'll show you how to do that here momentarily. I get y minus pi over 3 equals negative 2 radical 3 over 3, and there's an x there, plus 2 radical 3 pi over 3 times 2 is 6. Multiply everything by 6, both sides of the equation by 6. So I should be left here with, as I distribute this, 6y minus, so as I distribute, minus 2 pi equals, that's going to be 2 again, so minus 4 radical 3 x, and this is going to be plus 2 radical 3 pi, and the only thing left to do is actually move this over here, or you could leave it over here, either way. But the way that the book writes it out, it's easily comes out to be kind of weird. 6y equals negative 4 radical 3 x plus 2 radical 3 pi. And if I'm moving this over here, it's going to make it a plus 2 pi. So there's an equation right here for this. They don't like having fractions in their equation for some reason, and so they like to tend to write it kind of weird. And so there we go, start to finish right there. So we found the equation of the tangent to that line right there.